Okay. Welcome everyone. So as we discussed before, I'm going to give a brief introduction to model rocketry. Only going to touch on a few items, but we could certainly go into more depth. So just to start out, here is a diagram of a cutout of the Saturn V and a cutout of a simple model rocket. Obviously, the Saturn V, a very complicated piece of machinery. Model rocket, not so much. But they both operate on the same principle, which is basically sit on top of an explosive, light it, and send you where you want to go. So first thing is, you want to get into model rocketry, you need a model rocket. Number of places you can go for your first kit. Estes is probably the most familiar name. Any child who's gotten a model rocket for their birthday or for Christmas has probably gotten an Estes rocket. But they're not the only place you can go for such model rockets. There's a number of places. So first thing is get your rocket. There's an example of a starter kit. I thought this was appropriate given the Mars rover theme. This is a kit from Estes called the Destination Mars Colonizer. Comes with your model rocket, comes with a launch pad, which is basically a guide rail on a tripod. Comes with 2 engines that you see over on the left, look basically like firecrackers. A very simple electronics launch controller, and you've got all you need to get started with model rocketry. So question is, how high is your rocket going to go? Depends on the rocket, and then depends what kind of motor you put in there. Estes produces a number of motors, and just back up a little bit. Model rocket motors have a basic way they're described. There's a letter and 2 numbers associated with them. The letters refer to the impulse the rocket has, and basically it goes up by a factor of 2 for each letter. So a B motor will be twice as powerful as an A motor, C will be twice as powerful as B, and so on. The second letter is, the number after the letter is going to tell you what the average thrust is for the rocket or for the motor. And then the final number will tell you what the delay is before the ejection charge goes off. And I'll talk a bit about the ejection charge in a moment. So in general, you want your rocket to go higher, you're going to want to use a larger motor. So all things equal, a C motor is going to take your rocket higher than a B motor. But even within the same size motor, you've got choices to make. So for example, here, you'll see there's a bunch of C motors. There's a C6.5 and a C11.3. They're both going to put out 10 Newton seconds of impulse. But they don't necessarily burn for the same amount of time. So 10 Newton seconds, could be 10 Newtons for 1 second or 20 Newtons for half a second. So in this case, C11 would put out twice as much thrust for half the time. Now, why would you want to do that? In general, if you have a heavier rocket, you want a bigger punch to get it off the launch pad. A lighter rocket generally does better with a slower thrust because too much thrust on it is going to increase your drag, and you're not necessarily going to get that rocket as high as you might want to. Again, the rocket that I showed back here is a very simple rocket. You put in the motor, you launch it, and the motor burns out, it coasts, parachute comes out, and it lands. You can get models that have multi-stages. So basically, you have your motors in one on top of the other, and one lights, and then in turn lights the other one. You can also have clusters where you could have three motors going off simultaneously and get 3 times the thrust. So,
are they balanced? If you have 3 of them working simultaneously, are they
well, that's
well enough so you go?
Yeah, that's a harder degree of difficulty. You want them to all light simultaneously. You want to make sure they're pretty darn straight and aligned correctly. So yes, that the goal is to have that happen. Easier said than done. The upper stage, the boosters are a lot easier to work with, where you just have one that lights the other. As far as the delay charges, or the ejection charges on a delay, why would you have different delays? Again, if you're using a heavier rocket, after the thrust goes, it's going to coast for a while. Lighter rocket's going to coast further than a heavier rocket, so you might want to use a longer delay there. So this is just a very basic explanation of what's going on here. Here's an actual rocket we have. Very simple. You're going to have the rocket motor, which shows on the left there, goes in the bottom here. There's a little hook that holds it. It gets ignited by the launcher. It's going to take off. It's going to thrust. Thrust runs out. It's still running up for as long as it's delay on the charge. Then when the ejection charge goes off, it's basically going to explode upward. Out comes the nozzle, and then hopefully your parachute deploys correctly. And it lands, and then you can do it again. But parachute's not the only way you can land a rocket. This is, I thought, an interesting one that I've seen. It's a helicopter retrieval. So the fins of the helicopter blades are basically locked into the fins at the bottom of the rocket. Rocket takes off as normal, and then what the ejection charge does is actually punch out the bottom fins, and the helicopter wings deploy, and then it basically spins to the ground like a helicopter. If you're interested in how many of these Estes motors you would need to reach space, somebody calculated 65,000 rockets or 65,000 motors. But not likely to work.
How much does one cost?
The Estes rockets motors, they get a little more expensive as they get larger, but a packet of 2 C's or D's would probably be about $10. Oh. So you're looking at $5, $6 a launch.
No, I'm talking about this one.
Oh, this. not the most efficient motors you can find. You could, if that was your plan, you could probably come up with a better one.
Wait, is this a comparison to some Saturn V or something? Or like what
no. This is somebody asked how many SDs, I think it was the E-size rockets, would it take to get a rocket to space? And they did some calculations of, basically, how much thrust each of those have and how you have to set it up. And this is not to get to orbit. This is simply to reach the space line.
Okay.
Again, I think it's more kind of a sort of a joke question of, well, how many of these would I need? Obviously, I'm sure there'd be some complicated mechanics in how you would actually connect all these and actually get it to launch. So you got your model rocket. You enjoy doing it. You want to keep doing it. What's the next step? Join a rocket club. There's two organizations that generally people join when they're interested in model rocketry. One is the NAR, the National Association of Rocketry, and the second is the Tripoli Rocketry Association. Tripoli Rocketry Association does primarily high power rockets, and I'll speak in a moment about what that means. NAR does everything from those Estes rockets up until high power rockets. Generally, people start off at NAR, and then if they get very serious about their rocketry, they'll join Tripoli. But in a lot of cases, there's a lot of overlap in the people involved with both clubs, and often it's the same club at the same location. But the benefits are obviously you meet other people involved in rocketry, and generally the clubs will locate a space and have a regular schedule for launches, provide launch pads, technical assistance. They have competitions, rocketry competitions that you can participate in. And it's really a fun time. Tripoli is, as I said, more associated with high power rocketry. And there is an age limit there. You need to be certified for that, and you have to be over the age of 18 to get that certification. But I'll talk about that in a bit. So here's a picture from our local NAR club. That's my son there, putting a couple of rockets together. So across, you'll see one that says United States on it. That's a replica of a Mercury Redstone. The one next to that, you can see somebody had added a Star Wars TIE fighter to that one. The one after that looks like a little triangle. We call a snitch, and basically somebody just cut a piece out of a tin. It doesn't fly very far, but it's amusing. A couple other things. Sometimes people have fun with it. The one on the left was built with Dunkin' Donuts coffee cups. Doesn't fly very well, but it's interesting. And then around holidays, there'll be some themes sometimes. That's our Halloween rocket. We have to go up with our skeleton.
It seems you had flower pots on the at the bottom of the launchers.
Yeah, so we built our own launch rack there. Basically, it's a sawhorse, and then there's a 2x4 there. And then, yeah, those are clay pots, basically garden pots, on top of basically a small piece of metal. Those white handles you see, I believe we got those from a marine supply store. They're basically, you put them on the side of boats to hold antennas and stuff. And then the guide rails are basically just metal rods you get at Home Depot, and they're either an 1/8 inch or a 1/4 inch, depending on the size of the rocket you're looking to launch. And then over there on the right, that's obviously a designed for purpose launch system.
Oh, thank you.
Okay. And then the wires you see coming off. So I didn't talk about the injection. So basically, you've got that. Let me back up a bit here. So for the Estes rockets, rocket motors, they're essentially black powder motors. So they're like fireworks, except they don't explode out. They're engineered such that you get all the thrust in one direction, and basically you install a little what they call an igniter, and I don't have one here, but you think of this as like a little transistor, and you hook it up to a current, and just like a transistor would have high resistance here. There's a little high resistance piece at the top of the igniter, and there's a little explosive material they coat it with. And basically that gets put into the bottom of the motor. Then you pass a current through, it heats up the high resistance part. There's an igniter, it lights the black powder, and you're off to the races. So, and here's just a brief video of a launch. This is all right. So you might have heard somebody say, "Oh no," at the end, and that was because the rocket had separated, and basically we ended up with this, which is called a lawn dart. Basically, the rocket separated, so the parachute did not deploy, and basically came straight down. So it happens. So then after that, as I said, you can, Estes has a lot of, rocket kits you can build, and they have different variations on that. However, if you were interested in launching larger rockets, then you're moving into what we call high power rockets. And again, the difference between low power and high power is just based on the size of the rocket motors used. So low power is generally up to D, then E to G is mid power, but probably people would still consider that a low power rocket. You don't need to be certified for it. And then above that, you're into high power rocketry. And there's 3 different levels to that. you need to be certified. You can get certified either via NAR or through Tripoli. I think level 1 involves assembling a rocket, launching it successfully, having it recover successfully, and a few questions. Level 2 actually involves a written test in addition to some launch experience. And I'm not sure about level 3. And again, generally this is only open to individuals 18 years or older.
Quick question, the certifications give you access to more powerful rockets, but are there also requirements of like what you can launch from what areas? Like, are there any rockets you can just launch from your backyard, or do you need to go to a certified field for all of them?
Yeah, that's a good question. So, generally if you bought a simple Estes rocket and went to the local park and launched it, I don't think anybody would give you a hard time. Now, as a matter of law, like in New York City, I don't think there's any place that's actually legal to launch a model rocket. And they don't even sell, like if I go to the Michaels or the Target here, I'm not even going to find model rockets for sale, where if I go to New Jersey, they'll have them. But that being said, I don't think anybody would bother you. So one of the things the clubs give you, I should have mentioned this before, you get with the clubs is any sort of FAA waivers that are required, the club is going to do that for you. And it's going to vary by club and what the conditions are. So the club, the NAR club that my son goes to, they have an altitude limit of only 1,000 feet because it's 3 miles from a local airport and it's surrounded by people's homes. So they can only launch to 1,000 feet there. So essentially they can't do high power rocketry there. It's, just most rockets would go higher than that. There's another club that's about 4,500 feet. And again, it's going to be context specific. So, but if you're doing the high power rocketry, you're going to need an FAA waiver, which the club usually handles. Meaning they will submit to the FAA that we're going to be launching, on a certain day. They'll have a height limit, and they'll get a waiver from the FAA, and yes, air traffic control somehow communicates that to planes in the area so that they have that waiver. So yeah, you could buy a high power rocket to build. However, you can't buy these motors without a certification. So you're not going to be able to just get these motors. I mean, at least legally, you're not going to be able to buy these motors on your own unless you've gone to Tripoli or NAR at some point and were certified. So yeah, basically you need to be affiliated with one of these clubs to move into this more powerful level of rockets. So, and again, there's kits out there for all of these, but some people like to build their own rockets, and if you want to build your own rocket, plenty of vendors out there in terms of buying material you might need, body tubes or nose cones, or electronics. I should have mentioned before, also as the rockets get larger, they tend to get more complex inside. So for example, on an Estes rocket, you'll have an ejection charge that will shoot out your parachute. High power rocket generally isn't going to use an ejection charge for the parachute. It's going to have electronics in there, an altimeter. When the rocket takes off, reaches apogee, comes down, you set it for 500 feet, 300 feet, 200 feet. The altimeter will have electronics to release the parachute. So things get larger, they also get more complex. So if you want to build your own rocket, you can certainly do that. And generally you're going to want to use some software, and there's CAD software for rocket design. Two of the more popular programs out there are RockSim, which is commercial, and I believe that's made by Apogee Rockets. But there is a free open source one called openrocket.info. And then another site, a lot of builders use thrustcurve.org, gives you the motor data. So you design your rocket in RockSim or OpenRocket, and you want to see how it's going to perform with different types of motors. ThrustCurve will give you that information. So here, for example, is just a screenshot of a RockSim. And so when you're designing a rocket, obviously you have your goals in terms of, how big you want it to be, if you're trying to achieve a certain altitude or whatever metrics. But really what you want to, first things first is the rocket needs to be stable, meaning you want it to fly straight and true and, not go head over heels. And just the rule of thumb is there's two key variables you need to know for your rocket. One is the center of gravity, which is, I think, pretty self-explanatory. It's how is the weight distributed through the rocket. And the other is the center of pressure, which is related to what's the aerodynamic forces on the rocket. And that's a function of, what the surface area of the rocket is, how big the fins are, where they're placed. And general rule of thumb is you want your center of pressure, which is represented by the red dot, to be behind the blue dot, which is the center of gravity. That will give you a stable rocket. If the center of pressure is ahead of the center of gravity, you're going to have a problem. So a lot of what this software does is do these calculations for you. Now when we're out at a launch and somebody comes by with their home-built rocket, there's usually a person assigned as the safety officer. We have a sort of rough and ready way to deal with that, which is you estimate where the center of gravity is, you tie a string around it, you basically swing it around your head like a lasso. And if it's, if it goes straight and true without a wobble or doesn't turn, tail to head, then the rocket's stable. So that's sort of the rough and ready way to do it. Obviously, if you've got a 6-foot rocket or a high-powered rocket that weighs, several pounds, that's not going to work. But for, if you're building a lightweight, low-power rocket, that's how we test it in the field.
Does this kind of software takes into account, or can take into account, lateral wind and stuff like that? I wonder what, for example, a strong lateral wind would do.
I believe you can model those sort of effects in terms of how it would be affected, by the wind, because that's obvious. If you're going, if you're in a competition, going for, say, highest altitude or something. Obviously, a crosswind can affect how high it's going to go. So I think it does have some of that, but it's the primary focus is making sure that the thing will actually be stable and fly true and straight.
Do any of these higher power rockets, do they have active stabilization, like with fins that move and do some compensation, or is it all just passive fins for stabilization?
Yeah, so that's what I was going to talk about, passive versus active control. It's funny, depending who you speak to. Some people at NAR and Tripoli say that active control is forbidden, and it's not allowed per the rules and regs. And I should just back up a little too. So one other thing that the clubs provide besides the setup and the FAA waiver is also liability insurance. So as long as you're flying to club rules and following the regulations, and something goes awry, there is an insurance policy that covers that. And I don't think that's a small, especially when you're involved with these high power rockets. So people are particularly attuned to somebody coming in with just some crazy rocket that is unproven how it's going to fly. But sorry, back to active control. So there's one set of people say it's not allowed by the rules and regs. However, there are people experimenting with it in terms of for stabilization. So to your point about the wind, so like having a gimbaling or something, so to account for wind shear to sort of take it back. I've seen some of that, but the people I've talked to about it that do it, or the one person I spoke to, preferred, thought fins were more, activating the fins was more efficient, because especially at model rockets, the rockets, the motor's only burning for a very short period of time. And the gimbaling doesn't do anything for you after the rocket's burnt out. Whereas, you can still be playing with the fins after you're, while you're coasting. So I will say that. So there's this, I think somebody else had this video in there, which was, so they would not be happy if I showed up with that rocket and did that at a launch. So they're concerned about that. The other thing, and it's also active, within active control, there's, as we talked about, stabilization, and then there's guidance. And if you're messing around with guidance, you might attract attention from, authorities, because then you're looking at a missile in terms of launching it. So where it kind of fell out, like excessive stabilization, or stabilization of rockets, if you want to experiment with that, that's fine. You're trying to build a rocket to see if you can land it in somebody's pool or something, that's guidance, and that's probably, they're not going to allow you to sort of experiment with that. You know, and here.
How do they police that though? Because in the simplest cases, you could probably hack together something and you won't need any like, you know, sensitive components, and you could do simple guidance. Do they do like check of payloads and make sure you don't have like, you know, a heat sensor or something in there?
That's a good question. I don't know. I mean, we all know each other. We're all friends. I hope we know each other well enough. But you know, here, for example, is you know, something unfortunately that's been in the news a lot. This is the Javelin Missile, and if you look at it, it is really a model rocket, and in fact, it uses it's a two-stage rocket. It actually uses the same fuel that you know, some of those amateur high-power rockets use, and it has thin stabilization. Now, it also happened to have a bomb in it and some pretty, you know, I'm sure proprietary guidance system, but you know, it's a model rocket.
Do model rockets have a safety mechanism sometimes that if it starts squirming around on the ground, you press the red button and it, you know, blows up?
No, I mean, once you light that propellant, you know, it's going to do what it's going to do until it burns out. So no, there's no kill switch. So, you know, if you're enjoying rocketry and you've moved along and you're doing high power rocketry and then you start building your own rockets, if you're very adventurous and you have a, you know, chemical bent, you can get into rocket fuel. You know, briefly, all the SD's motors are simple black powder. So like I said, they're like fireworks. They're just a cardboard tube stuffed tight with black powder and then basically capped at the end with a little nozzle to direct the thrust, and you light it. When you move up to larger rockets, black powder, one, is not very, you know, efficient. You don't get as much bang for the buck, you know, impulse for the weight involved, and it's the bigger black powder motors can get up unstable. So if you have like a D motor, you know, sometimes if it's old or whatever, or you dropped it on the ground or something, it develops a little crack and, you know, just blows up on the pad on you. So it's not a desirable fuel for larger rockets. What they do use, what's most popular is what they call ammonium perchlorate. And again, I'm not a chemistry expert, but it has, you know, better, you know, impulse to weight than the black powder. It's easier to work with. It's a solid propellant. It gets made. It basically is sort of has the consistency of almost like a big pencil eraser, you know, sort of rubbery like that. They sell them the same, you know, you can get them either the same way you would buy an Estes black powder motor, which would be a one shot, one use, or they also build them as a composite rocket, which is sort of like a reloadable sleeve. So you can buy, just like I said, it's a solid, almost like a pencil eraser. You can you launch the rocket and then you can take that canister out and reload it. I think it gets a little cheaper because it does, the price of these motors does go up as you move up the scale here. Another type of rocket motor that is in use now is called a hybrid motor. I have a picture of that here, and that is a combination of liquid and solid propellant. They generally use nitrous oxide as the liquid part, and then there's a couple of different, I think actually it's some type of PVC that they use as the solid part. But you can see here, this is you know, quite a ways up in complexity from the black powder rocket used by Estes. So you could probably spend you know, as much time as you spend talking about model rockets, you could spend that much more time talking about rocket fuel. And
Brian, can I stop you for a minute?
Sure.
The picture you just showed, it looks very similar to this object I picked up on a walk a few months back. Is this a burnt out rocket motor, you think?
It looks awfully similar, right?
It's a bicycle inflation cartridge.
Is that what it is?
Oh, okay. I was hoping it's a burnt out rocket motor.
Or, well, it's, I mean, nitrous oxide is used, you know.
This is aluminum, but it looks very similar, yeah.
Yeah. Yeah. So, but as I said, yeah, we've moved quite a ways up from the Estes rocket we started with. But if you're very adventurous, you make your own rocket fuel. And this is there are some people who are very, very committed to making their own rocket fuel. And again, you could probably, you know, you could devote a whole session just talking about rocket fuel. And you'd be surprised, made out of very common materials: sugar, hydrogen peroxide, ammonia. A very popular one is a sugar-based propellant, and they call it rocket candy. So I was very surprised when I heard about that. But if you saw The Martian, I don't know if you've seen the movie, but at one point they had to slow down the ship, and they needed to blow a hole in it to evacuate some air and cause some counter thrust. And I don't know if you remember, but they blew a hole with a sugar bomb. So, and this was in the news. It just happened to be in the news 2 weeks ago as I was putting these slides together. This is, I think, at Brigham Young University. Somebody was cooking their own rocket fuel, and this was the result. So I would not, it's not for the faint of heart. That's for sure. And if you're, you know, if you're interested in reading more about rocket propellants, this was just a book my son recommended. This is for liquid rocket propellants, so you know what goes into the, you know, Apollo, Falcon X. But he said this was a very interesting book, and I just noticed it had a preface by Isaac Asimov, who I think we're talking about the 3 laws of robotics. And if you want to move on from there, there are people there doing, you know, real experimental rocketry with, or you know, even beyond what you're going to get at the Tripoli Club. There's quite a few places. I list these two. I think they're both in the Mojave Desert somewhere, and you know, they're launching things probably 40, 50,000 feet. But if there's a long way to go with model rocketry. Just wanted to mention that. And if you're not interested in or can't get out into a field to launch your model rockets, another interesting way to get exposure to is a Kerbal space program. I don't know if anybody's heard of Kerbal, but it's I don't say it's like Minecraft, but it's a video game, but it has a pretty good physics engine for launching, for rocket launching. Here's a screenshot of it. And one thing I discovered is you can actually build a rover in Kerbal as well. I don't know if the rover physics are that accurate, but I thought that was interesting. And this was I thought a funny XKCD cartoon. So there's, take physics, get a job at NASA, play Kerbal, and then you'll really understand orbital mechanics.
Yeah, it's really good for orbital physics. So if you want to launch something, and then it will give you reasonable accuracy on the orbits. Yeah.
So if you don't want to, if just launching rockets into the air is not enough, you can go to Kerbal.
All the time I spent playing, I never once got anything into orbit.
No,
it's very difficult.
It has I've had a hard time with it, and then my son was playing it one day, and like he was doing great. Like I think it's like Minecraft. It has an easy and a hard mode, so you can turn off a lot of the physics and just build some ridiculous stuff as well. But I thought it was challenging and fun to play. So what does this have to do with rovers? I'm not sure. All of these model rockets, payloads are not, or at least from what I've seen, are not the main interest in that. So I haven't seen anybody trying to launch rovers or robots. And again, these rockets can't lift a whole lot. So unless your rover is very, very small, you're not going to be able to do much. The one organization that does do something with this is NASA. They have a NASA student launch competition. Generally, it's college teams, and they're launching high-powered rockets. So these are high-powered rockets with payloads, 2 or 3 kilograms, which is a lot, relative to the other rockets we were looking at. But the past few years, they've added some rover-like elements to their competition. So this is just a sampling of the last few years. One is you need to be able for your rocket to locate where it has landed without the use of GPS. Another one was develop a lander system that will land, self-assemble, and take a picture and transmit it. And then another where it will land and collect some samples and then travel a set distance. Unfortunately, I couldn't find any pictures of the actual, anybody actually launching this and completing any of these competitions. However, I did find this is Vanderbilt University testing one of their landing vehicles by throwing it off a parking garage. So But when I went to their site to see the actual launch, it looks like the lander did not make it in one piece from the rocket. So, and then just to end here, I think somebody posted this in the Discord of rovers that are going to the moon. And I did notice there's actually 2 that were there that are actually, their form factors are quite small. One, this lunar rover from Japan, which is supposedly the size of a tennis ball, and only weighs 250 grams, and the Colmena, which is even smaller. These theoretically you could fit in a model rocket. So maybe there's something to work on there if we can develop rovers small enough to fit in the payload of some of these rockets we talked about. That's all I had. I realize that's a very, very brief overview, and probably missed quite a lot. So if there's any questions, feel free.
I have a question about your colleagues. Do most of them go into this because they're interested in things blowing up and things flying high in space? What reasons do people have for doing model rocketry?
I mean, the club I belong to, it's an interesting. It's a lot of kids. So, like myself, a lot of people take their children out there. My son was very interested in space and rockets and that, and that's how I got involved in it. And then there's an older contingent. I think they like I think they like lighting things up and sending them up. I don't think they're so much interested in, I mean, they're all probably interested in space exploration, and they know what's going on, and certainly know the whole history of Apollo and whatnot. But I think they like just shooting things in the air.
Mm-hmm.
Sort of related question: to what extent is it people who are interested in kind of like the aesthetics and design and stuff? Like you showed the TIE fighter and I don't know, that Halloween skeleton thing, and then other things looked like they were like technically really complex. So what's the divide between those 2 groups?
Let me go back here. So were you referring not to this picture? Or?
And this one has a TIE fighter in it, and there's these sort of gimmicky things.
Yeah, there's a lot of gimmicky things, and then I guess another thing I to mention. There's some people who built extremely detailed, historically accurate models. So a Saturn V that would have details on it. You'd look up close and you'd see amazing detail. So that's sort of another subset, if you want, of space modeling, where people are building very accurate representations. In terms of these rockets, all these rockets are kits, right? So not like even the one on the right is built from a kit. Again, some I mean, I've built a few rockets, myself that are not kits, but they're, using off the shelf parts, right? So I get my own body tube, I get my own nose cone and do that. And I do some basic calculations on it. But I know as you move up to the high power rocketry, then people are really designing their own stuff. That's well beyond my abilities.
Talking about the link with the rovers, so we are often in the context of where we'd like perhaps the rovers to operate in space, so they would need to be launched to get launched. And so, of course, the link is here, but practically, if we come up with some plan, like we say, okay, we target to make a rover that must weigh less than 1 kilo and must fit, in a CubeSat unit, basically. If we come up with such kind of requirements, is it possible? I guess it's possible to calculate then the rocket requirements and a bit what you explained at the beginning.
Yeah.
And do you think it's possible to have maybe not the high power rocket, so something that doesn't need all that certification and so on, so that perhaps maybe it's interesting to investigate, making a rover and trying to launch it to see how it reacts and how it lands?
Right. So yeah. So that's what I was trying to think about at the end there. It's going to have to be a very small rover if you want to sort of use rockets that you can test a lot, right? Because even for that NASA student launch, you build a rocket, they're not launching it on campus, right? They've got to find some place where they can to launch that high, and maybe they get 1 or 2 launches in. But what I was thinking, if I was trying to figure out here, well, the maximum lift weight on an E here would be 283 grams, which is still not a lot.
Ah, wow, okay.
Yeah, it's
actually for rovers, I don't think that's actually the most interesting and relevant way to think of it. Like, we are not actually interested in doing modeling of the launch phase of a rover mission. What's more interesting is the descent phase. Like Perseverance used that retro rocket landing platform that kind of there's a parachute stage for a long period, and then at the lowest phase, the retro rockets fired, so it wasn't actually going up; it was going down. And then it dropped the rover, and then it kind of blew off to the side, if you remember, right? So that scenario seems like it should be possible to simulate kind of easily. So you would drop the whole thing off the top of a tall building, and you don't want it to actually have enough thrust to overcome gravity. You just want to slow it down. Can that sort of scenario be made? That sounds like it would be easier, at least power-wise, or power-wise.
So I'm sorry. So that wouldn't require a rocket at all, right? Just a tall building.
No, that is if you're using a parachute. I'm talking about simulating the way Perseverance was landed on Mars, which was the first phase was a parachute descent, but then they used retro rockets. So literally that landing thing had 4 rockets that were firing, and it descended slowly. It lowered Perseverance on a set of looked like chains or something, or cables.
Right.
And then it had a final separation thrust where it kind of dropped the rover and then blew off to the side. So it's basically descent phase rocketry, not ascent phase.
Oh, okay. I'm sure. Can we do descent phase rocketry?
Yep.
I think the only place I've seen it so far, the guy who was doing the gimbaling Oh, where'd he go?
So this is,
So he,
yeah, that's the kind of thing I mean. That would be fun to try and do because you need much less power to weight ratio to just slow it down enough that you don't break the rover.
right. So he just, he just took that up on a drone and dropped it.
Yeah.
Certainly possible. Somebody did it.
And I think you could get a fairly big payload in that scenario, like not 280 grams, but like, maybe up to a kg or something. But yeah, that's something to think about in our sort of potential ideas missions.
Let's say a 5-kilo Rover, which is small. How many of what kind of rockets would it need?
A 5-kilo rover?
Yeah, just for slowing it down. Well, slowing it down to, substantially zero.
So no parachute at all.
I'm willing to have a parachute. But, it's like Mars, so you have to assume the parachute won't do much.
Right.
Yeah, that's actually a good point. I think to design the simulation right, you'd account for the lower density of Mars atmosphere and sort of compensate the parachute design. So something like, a 10-foot parachute on Mars is probably equivalent to like a 2-foot parachute on Earth. So you would sort of make that comparison and do that, and then sort of compensate for the rest with the rocket.
Well, I don't know
Yeah, that would be like, I don't know, a couple of hours of calculation to figure out, I think.
Yeah. But I mean, if it was something, in the EFG range, then yeah, you could do that without getting into all those other regulations.
Is there any limit on just how many EFG motors you could put on one project?
65,000.
Well,
so we can definitely slow down a rover.
Well, if you go to always the limit for amateur rocketry. So after that, you're an experimental rocketry. So if you want to go use a AAA launch site, that's going to be 40,960 Newton seconds. They don't care if it's 1 slug or 10 slugs. It's the total impulse. Right. So however you divide it up.
Oh, I see. Okay.
Yeah. They're not going to let you do 10 O's together.
So the certifications are by the thresholds of total impulse. So you need your first certification at 320 Newton seconds.
Correct.
Okay, got it.
Correct. Right, and then you'd be certified to fly H's and I's. But again, I'm not. There are, like I said, if you go out to the Mojave Desert, there's people operating beyond that range.
I'll take a shot at calculating like the simplest experiment that you could do with a very low power based on this chart, because I think the physics should be fairly simple. You want from say 5 meters, if you drop it, it can't gather that much acceleration in that short of thing. So it shouldn't be hard to figure out how much it'll be. So yeah, it might be fun to at least do a paper exercise in figuring out a simple rocket descent.
Right, and with there are. Well, I mean, especially when you're developing your own, rocket motors, right? That all H motors would not be created equal, because you could create one that burns twice as fast. So that might work better for you, from a shorter distance, because it's going to give you, it's still H powered, but it's going to use up all that power twice as fast. I thought somebody else was delivering the rover for us to Mars. That was SpaceX's job.
Yeah, the last mile. Who's going to do the last mile?
Oh, aren't they actually gonna land and
I'm sure there'll be actually proposals in the next 10 years. Like I've seen like concept missions of like a lander dumping a whole bunch of like micro rovers, like hundreds of them. I think it was in somebody's talk in this group. But yeah, so people are talking of those concepts, but I mean, nobody's actually proposed a concept yet. So it's conceivable they'd offer concepts like, all right, we'll take you up to Mars and then just drop you in the atmosphere. It's up to you to do the parachute and descent stage. So it could be that SpaceX or somebody else may offer that kind of service for much cheaper, right? Because I think it would be interesting to do the budget. I suspect it's going to be one of the most expensive phases of the mission is probably going to be the descent into Mars. So yeah, worth sort of figuring out if this is doable.
Also to locations, which we maybe SpaceX goes to standard locations, and then if you want to go to a location which is not provided by SpaceX, they just drop somewhere.
Yeah. But yeah, I think this is worth at least figuring out to first order, both parachutes and this. I wonder if we can find somebody to give a little talk on parachutes.
Yeah. My son's engineering teacher at school, I'll ask him, because he worked for SpaceX and all he did was parachutes at SpaceX for the year he was there.
That sounds like the guy.
I'll ask him.
That's who we want.
But he's not there anymore, so maybe he gave up. I don't know. So, I mean, I realize that was probably a very cursory overview. But beyond the sort of looking into this sort of counter thrust to land a rover, anything else that people had questions about?
How big is the group that you're part of? Like, go to a launch day. How many people are there?
It's probably 20, 25 people. And they probably launch, on a good day, 40 to 50 rockets.
Wow.
Yeah.
I was just browsing around looking at what was local here in Seattle, and it looks like there's a group that on their website, it hasn't been really well updated in a while, but it looks like they used to have like big, like Memorial Day weekend meetups out at some launch range, and they would just like camp, launch rockets, like a big kind of social event type thing, which is kind of interesting.
Yeah,
but then they do more frequently, more like there's one in Renton, I think, that they launch occasionally.
I think if you're out west, you probably have a lot more choices and a lot more capability to launch some interesting stuff. In the New York City tri-state area, you're pretty limited. I mean, we're limited to 1,000 feet, and that's 70 miles away from here. Because there's basically severe limitations anytime you're within 5 miles of an airport. And there's that's any private airport. So it's New York, New Jersey, Connecticut, you're not going to find a wide open space that they're going to let you launch to 10,000 feet.
Yeah, I think this location was out like east of the Cascades, out in the desert somewhere. So
I think I looked at the same one, Red, since I'm planning to move back to the Seattle area. The altitude limit there was 14,000 feet. So it's about 3 hours out east of Seattle. So it's a little far, but for 14,000 feet, I think it's worth going there.
Yeah, that'd be kind of cool.
Yeah. And then it needs to be, at 14,000 feet, your rocket can travel pretty far away on the way down. So that's the other thing of, around here, we use an athletic complex that belongs to the local school authority. So it's maybe 10 soccer fields, but that's not really all that much. A lot of people a little further out, if you just find a friendly farmer, who's willing to let you launch on his, property. That's your best bet out here. But I imagine, the Mojave Desert, go as far as you want.
I was wondering how you get the engines themselves. Like, are there stores? And then I went to the Estes Rocket website, and they literally will just mail them to you in the United States, which seems unfathomable that I can just have a rocket motor mailed to me. But
well, so up until like the mid 2000s, I believe all this stuff. Well, definitely the ammonium perchlorate was regulated by the ATF. So you needed like an ATF license to work with this stuff. And I think somehow they lobbied them to take that off the list. So you can buy black powder motor. I mean, you can get Estes rockets in Target, or any hobby shop. You can order them. They do have to ground ship them. They won't fly them to you. So no Amazon Prime. And like I said, if it's a high-powered rocket, you're going to have certification to purchase it and be over 18. But yeah, there's no limitations. I think there are limitations on buying black powder, like that. If the amount you're buying exceeds a certain size. But yeah, they'll mail them to you.
I wonder what it's like in other countries. Does anybody know?
I don't.
Japan is too narrow anyway, so no space here. No space, literally no space, flat.
No space to launch?
No, we do have two official. There is the Japanese JAXA, which is the Japanese equivalent of NASA, but they have their own island in the south of Japan. Okay, and actually it's an island near a volcano. Okay, so I don't know. And there is another site for a private company in the very north of Japan. So it's actually pretty close to Russia actually, which is the only area in Japan where you have very wide flat spaces basically. Okay, most of Japan is 60% mountains basically, and the very high density. To give you a comparison, is that Japan is 70% the size of France, which is a tiny country, but it's twice the population, and it's more than half here is just mountain. So I know we have very strong, very strict regulation for drones already, because here robotics is very popular with many people. Okay, and so very quickly they prevented to use drones. So I can't imagine anything about rockets. Sorry. All that to say, I just don't know actually. In the US, there are a lot of states where I don't know, my image that is very, very, very large spaces where there is basically no one, especially in the central states, right?
Oh yeah, it's wide open deserts.
Victor showed us a little bit around his house. I wonder whether it should be not the YakRover launch site.
Yeah, you could. I bet he could launch something from there. Oh, except fires are a bit of a concern, I suppose.
Ah, it's very dry over there, yeah?
Yeah.
So, sorry, Mayor, are there rockets that launch from Israel?
That's a very sensitive point. Remember, we have rocket defense systems waiting for somebody to launch a rocket. I wouldn't even ask for permission. Okay, we have neighbors that are experts in rocketry. So we have big, wide open spaces, but I can't imagine anything good will come of it.
Indeed. What about in Finland? In Finland, I think there is a program a bit like Sweden, right?
So there is a lot of empty space here, but I've never heard of a rocketry club. But I should look it up. So the population is also density is quite low, so there is a lot of forests and empty spaces.
But also, as part of Europe, perhaps a lot is maybe like in Sweden, where in Sweden there are research institutes where they do part of the ESA program, but I don't think they do anything more than that in Sweden, at least.
So in the northern part of Finland, there is a sounding rocket near Kiruna. It's called Esrange sounding rocket. And, Sweden is investing more into that place so that it can carry larger payloads. So it used to be like a student. So the students could send small rockets, like payloads on that and satellites on that rocket.
How well does GPS work in Finland? I understand if you get the higher latitudes, it's less accurate. Is that true?
I have not faced any problem with it. It has to, like, I don't know the exact accuracy, but it seems to be okay on the phones at least.
Yeah. So you put your phone on a rocket. Yeah, okay.
I think it's about 80 degrees north where GPS stops working well. So Finland, the cities are not that far north, right?
Yeah, so we are around 65 I am living at 65.
Okay. Yeah, the Russians, they have the Molniya equivalent of GPS, which is this really high inclination orbit, like 60 degrees. And the reason is exactly that higher latitudes GPS doesn't work. So instead they use their own Molniya system. All right. Yeah, that was great. Thanks, Brian. Now I'm at least inspired to go check out one of these launch events and be a spectator at one of these. Sounds like it's fun to watch.
I mean, I've got plenty of these rockets lying around. If you want me to send you one.
Sounds like